If we look at the event args classes that we introduced earlier in the course, we can see that one of the warnings produced by enabling nullable reference types is that we have not set the property order to an instance. It's telling us that this is a non-nullable property, and it cannot determine that this has been set to a value once the class has been instantiated. It doesn't matter if the property is immutable using the init keyword. That alone doesn't ensure that this has been set to an instance. One potential way to solve this is to introduce a constructor. When you introduce an empty constructor, the warning moved from the property to the constructor, as the compiler now determines that it would be appropriate to instantiate all the non-nullable members of the class in the constructor. To do that, you'd have to require the order to be passed as a parameter. There are no longer any warnings in the class. However, we changed how this class is used throughout the application. So if we compile this, we may get a compiler error where this is used, because we no longer support an empty constructor. The type is only used in a couple of places. Going around and fixing those errors may not really be an issue. Instead of setting the property when creating the event args, we'd expect it to be passed to the constructor. Although, was null really an issue inside this class? The null reference exception would have occurred where the order property was accessed. While it would definitely be a good idea to always make sure that we set our reference types to an instance, changing the contract of how this class is now constructed may be too big of a change. Let's go to the other event args class that has a similar warning and look at an alternative approach. For the order property, the compiler hints that we could make this nullable, just like you may have previously done when creating a nullable value type. You can now explicitly indicate that a reference type can be nullable as well. If you indicate that the order property is a nullable order, the warning goes away. We didn't fix any potential null reference exceptions, but we've now told the compiler that anyone that uses this property needs to make sure that it's not null. Let's go to the program and make sure that we have an event handler. Inside this handler, we'll use the event args and access the order property. Then we'll get the order number from the instance. Look at that! We have a warning. This is because the compiler knows that order can be null. We'll look at different ways of guarding against null in the next clip. But for now, let's just use the null conditional operator. This helped us prevent a potential null reference exception. We still have a lot of warnings, and I'd recommend that you pause the video and try to fix these on your own. Sometimes it's okay that a reference is set to null, as long as the intention is not ambiguous. In the order processor, these delegates and event handlers on the processor are optional, and thus we might just allow these to be null. The compiler will then tell us if we use these without guarding against null. Everywhere in the application where you use a reference type, you may declare that it's nullable. Keep in mind, all reference types are now determined to be non-null by default. If we make a call to the process method and explicitly define that we are talking about the overload, that accepts a list of orders on the order processor and pass null. The compiler will tell us that this is not appropriate. The method expects this to be instantiated. While the application may still work, the compiler has no idea if the method handles this internally. But the whole purpose of nullable reference types is that you can indicate that you do not wish to receive a null reference. If you tell the consumers of the method that you want them to pass a reference, that means you can remove unnecessary null checks. Of course, there's no guarantee that you won't get a null anyways. One of the limitations of nullable reference types is that it won't know if each element in an array is null or not. If we pass an array of orders where each position in the array hasn't been instantiated, the warning disappears, but we can see that we'd still have an issue. It's not a silver bullet, but in most cases, it will provide a great amount of help to determine if there is a potential problem. If we change this up a bit and create an array of orders where this array contains one null reference, of course, this provides a warning because we've declared that we have an array of non-nullable orders. We may indicate that this is an array of nullable orders. This will then provide a different type of warning. The method signature and what we pass to the method is now a mismatch. The method expects an IEnumerable of non-nullable order. If we go to the method process, we could indicate that the entire IEnumerable may be a null reference, or we can define that we require an enumerable, but we don't care if the order is an instance or not. Look at what happened further down in this method. We're now getting warnings that this may cause a null reference exception. This was just an example of how flexible you can be when you're enabling the nullable reference types. Let's revert this method back to indicate that we want an instance of an array, as well as each item in that array needs to be instantiated as well. We don't want to have any null references at all. As mentioned earlier, it may be overwhelming if you are converting an old project to use these nullable reference types. We looked at enabling or disabling this feature on the project level. The fact is that you can do this using a compiler directive as well. If you add the compiler directive nullable followed by your setting, for example, nullable enable, nullable disable, or any of the other options available, this can be applied anywhere in the code and applies only to the context that you use it in. You could enable the nullable reference types only for a particular if statement, a method, a class, or an entire file. This lets you gradually improve the entire project by looking at one portion at a time. This is a good alternative if you are maintaining an older project. We've seen how to enable the nullable reference types, how this changes the way the compiler looks at our types, and how to indicate the intent of what a reference type is. Next, we are going to talk more about guarding against null and try to avoid null reference exceptions.